Hey everyone, in this episode we're going to create our first entity from scratch and dive into ECS syntax. I know you're all raring to go, but we're going to take baby steps. We will just create a simple object and get acclimated to this very different way of working. There's a whole new UI to learn and an entirely new methodology. Remember that Unity DOTS is a number of things. ECS, the job system, and the burst compiler. Let's take them one at a time, and we'll start with ECS, which is quite a large topic by itself. ECS stands for Entity Component System, and we're going to start with entities. Before we can do anything, we'll need to set up our project for DOTS, make a fresh Unity project. You'll need to use Unity 2019.3 or later. And I'll make this a basic 3D project where you can choose one of the SRP templates as well, but that's up to you. In the window package manager, you will absolutely need two packages, the entities package and the HybridRender package. Once those are installed, we can start with a mono-behavior script. This will serve as a bridge between working in quote-unquote classic style and the new data-oriented style. I'll call this spawner since that's what I'm going to use to spawn our entity, and let's stay organized with a scripts folder. Inside of our mono-behavior script, I can gut everything except for the start method, and we'll also need to add an extra using line at the top using Unity entities. This imports the resources that we need for ECS. Now let's create a private make entity method that returns nothing and takes nothing as an argument, and we'll invoke it straight away in start. Before we get too deep into scripting, we should get some terminology straight. In ECS, we'll organize everything as entities, components, and systems. Unlike mono behaviors, where you can mix data and actions or methods, we split them into smaller pieces. Entities are things in your game, components represent data in your game, and systems are the logic of your game. Now don't worry about the specific syntax of each one, we'll get to that, but keep this structure in mind. Everything is split into entities, components, and systems. Things, data, logic. And that's probably as simple as I can distill it. Organizationally, there's also a world that includes all of the game's systems. And there's also another structure called an EntityManager that manages all of your entities or things. We have one entity manager per world. When you need to do something with an entity, create it, assign it data, destroy it, you're always going to do that with the EntityManager. In the spawner script, let's create a variable, EntityManager. To get a reference to the current entity manager, I'll grab that from world, default game object injection world, .EntityManager. I know this is a slightly longish name, but really this just means our current default world. Remember that I mentioned that we have a world holding all the game logic, and each world has one entity manager. This static entity manager gets a reference to it. We're always going to use the entity manager to create entities, and you'll do that with the create entity method, EntityManager.createEntity, and that should create our first entity. Don't get your hopes up. This is going to be very anticlimactic, but save the script and let's try it. Create a game object to run our script, and I'll call that spawner as well. Drop the spawner component in there. Hit play in the editor. And okay, so what gives? Did something happen? Well, it did. We created an entity, but you'd never know it by looking at the hierarchy. Entities don't exist here. To see the results of make entity, you really need to go to the EntityDebugger. And you'll find that under Windows, Analysis, EntityDebugger. Whenever you're working with ECS, you'll dock this window somewhere or keep it close, somewhere accessible because you'll refer to it often. If you look at the left column of the EntityDebugger, you'll see an entry called All Entities Default World. If you click on that, you'll see in the middle column we have two entities, and they're numbered, not named by default. Entity 0 is something we get automatically. If you select that, you'll see that it contains our game clock, everything related to time in our game world. In the third column, the EntityDebugger shows you the memory chunk corresponding to entity 0. So this chunk of data has two different data types, the world time and world time queue. The chunk shows you the data types. To see the actual data, you need to look at the inspector. And sure enough, you can see our actual world time and world time queue, and you can see the real-time data that is incrementing every frame. Unity created entity 0 for us automatically. Entity 1 is what we created with our script. If you select it, you can see that, well, there it is. The corresponding memory chunk is blank, and the inspector is essentially blank as well. An entity by itself is not really meaningful. In ECS, an entity is just a thing that references other pieces of data. Without any data, it's just an ID with nothing to point at. The idea is that a thing in your game, an entity, is just an identifier. The data itself is somewhere else, and that's the important thing, and it's not actually contained within that entity. So let's just think back to working with model behaviors. In what we call quote-unquote classic Unity, if you create a game object, and let's just do that for argument's sake, whenever you make an empty game object, you get stuff automatically. It contains a whole lot of things by default, a transform, a name, a tag, a layer. Even though these fields might be blank or uninitialized at 0, they always come with a game object. And sometimes that's convenient. But each little piece takes up a small bit of memory. When you have one game object, then fine. But if you start to add hundreds or thousands of game objects, you'll start noticing their inefficiency. Entities don't have that issue. They're just numbers, integers in fact. You need to assign data to them in order for them to be meaningful. So let's go back to the spawner script and see how we can do that. And I'll preface this by saying that I'm going to write a lot of code here that you won't necessarily need to memorize. I'm writing it out so you can understand the process of what's happening, but I'll show you a shorter syntax of doing the same thing later. So just humor me for a moment. To assign data to our entity, first let's decide what type of data we want to give it. We'll do that using what's called an archetype. EntityArchetype, archetype, equals EntityManager dot create archetype. And inside of here, we'll just pass in a bunch of data types. Unlike game objects and model behaviors, we don't get any transforms or rendering by default in ECS. We need to import separate resources that Unity has built specifically for this purpose. At the top, add a using Unity transforms, using Unity rendering, and using Unity mathematics lines. Inside of create archetype, pass in type of translation, type of rotation, type of render mesh, and type of local to world. These two give us the ability to move and rotate the entity in world space. We need the render mesh to draw the entity on screen, and local to world is something that you just need to transform the render mesh into world space so it can be seen on camera. And then we need to pass the archetype into the create entity method. And that does some basic setup for our entity. So let's just check it out in the EntityDebugger. If you save the script in Unity, again, nothing shows up in the hierarchy at runtime. It doesn't really look any different. But in the EntityDebugger, we suddenly added some extra data types to the Entity1's memory chunk. If you select Entity1, you'll see the archetype represented here in the third column. The memory chunk contains local to world, render mesh, rotation, and translation. The inspector is no longer blank. It has some extra fields that correspond to our archetype. But the fields don't have any values. They're all just uninitialized. To add some data, we'll need to go back to the script. In the spawner, reserve a couple of fields for a mesh and material at the top, and I'll just serialize a couple of private fields, unit mesh and unit material. That makes them visible in the inspector, one of the benefits of keeping this as a mono behavior. And then down in the make entity method, let's arbitrarily assign a translation value. And we'll do that with the EntityManager, of course. EntityManager dot add component data. Remember that the C in ECS stands for component, and remember that component really just means data. So add component data will add some data to our entity. We need to specify which entity as the first argument, and then pass in the data itself as the second argument. So let's first temporarily store our entity somewhere. Entity by entity equals the results of this. And now in add component data, let's assign our entity to a world space position. For example, I'll move it to a coordinate of, say, 204. So my entity is the first argument, and then I'll pass in the XYZ coordinate as the second argument. To do that, I'll use a new translation object, and inside of this new translation, I will set the value to a new float 3204. And you'll see shortly that a translation is just a struct. It has a value member variable that we can set to a specific 3D coordinate. We get this translation from Unity Transforms and float3 from Unity Mathematics. And that's why we needed to add those using lines earlier. Again, these are things that Unity created for ECS and DOTS because A, you don't get them for free from mounted behaviors anymore, and B, they're much more memory friendly and efficient. Now, once you do that, you should see our entity's position in world space. But to make it visible, we'll need to assign the entity a mesh and material. And we'll do that with a slightly different method called add shared component data. EntityManager dot add shared component data this time. Again, the entity goes in as the first argument and the data is the second argument. So we pass in a new render mesh, and inside of this object's curly bracket notation, you set the mesh and material. Whereas translation only had a value field, render mesh has a mesh and material. Mesh equals unit mesh, material equals unit material, and that should assign whatever we specify in the inspector. Save this script. In Unity, I already imported a material and mesh to populate these fields. In my materials subfolder, I have a blue material called CubeMet. Nothing fancy, just make sure that you go down and check GPU instancing. Though this is not particular to DOTS, we will be rendering a lot of these objects later. Having this checked means that your GPU can help you reduce the number of draw calls in your scene when you're rendering the same mesh over and over, so that should only help. I also have a beveled cube mesh in the models subfolder, scaled to meters. Feel free to use one of the default primitive models that comes with Unity, or substitute any mesh of your own in here, the Blender monkey, a giant robot, whatever you want. Essentially, you want to assign the mesh and material correctly in the inspector. Then, in play mode, we now get a blue cube at world position 204 as we would expect. Note that you can't click on the cube in the scene view. There's no way to manipulate an entity like a game object, just like there's no way to see an entity in the hierarchy, but it is there. That's just part of working with entities at the moment. With DOTS, you're using the HybridRenderer package to draw your cube on screen. Your camera and light are game objects in this case, so the HybridRenderer connects those with the ECS world. Otherwise, the entity cube couldn't render. And you'll see that in the EntityDebugger, it does add a few components to do that. Chunk world RenderBounds, RenderBounds, world RenderBounds. The HybridRenderer supplies those automatically. And you can see their specific values in the inspector. And we can scroll down and see the position of the entity itself, which the inspector confirms is at 204. Okay, so we've created a cube, no big deal. The key takeaway here is that the cube is not a game object. It's an entity. We've created some data for a mesh, created some data for a material, and some data for a 3D location. Our entity essentially just links those pieces of data together, and then Unity and the HybridRenderer knows to draw the object on screen. Of course, if you had to do this every time you wanted to display something, you might pull your hair out and just give up on DOTS and ECS altogether. There's a lot of boilerplate here just to do something very simple. Now don't worry, it does get easier. I just wanted to break this process down so you can understand what's happening. First, we get a reference to our world and EntityManager. We define an archetype of data types, and then we create an entity using that archetype. Once you have the entity created, you assign specific data values using add component data or add shared component data. In our case, we dropped in a mesh and material from the inspector, and we hard-coded a world space position within our script. Now feel free to test out different values for the material or mesh, or draw the entity at a different point in space. If you're adventurous, you can add a new scale or rotation value if you want to continue exploring how to do this in what we call quote-unquote pure ECS, where you build entities completely within code. Now, while it's good to know the syntax, and having all of these in a script gives you flexibility, it can be a little tedious to set this up each time you want to create an entity. Fortunately, there is a relatively new conversion workflow that simplifies this process, so let's check that out in the next episode.